Mechanical engineers must master a broad range of skills, possibly the broadest of all of the engineering disciplines, but in turn that allows them a wide range of career opportunities and choices. So what sort of things do mechanical engineers do? A mechanical engineer might design a machine that converts energy, like this turbine that's been tested in the department's wind tunnel. They design machines that move efficiently through air or water. A mechanical engineer might design or test a structure that has to withstand millions of cycles and operate safely over a long period of time. And mechanical engineers design manufacturing operations that have to run at the lowest possible cost. Increasingly, mechanical engineers are turning their skills to help doctors and clinicians diagnose and cure diseases. Mechanical engineering takes science and makes it work for a living. The mechanical engineering course is designed around thematic lines, the 4 themes that you see here, and a strong theme of design which runs through the whole of the course. In thermodynamics, we look at the relationships between work, energy, and heat, and then apply those to refrigeration, air conditioning, to fuel and engine efficiency. Fluid dynamics looks at the interaction of fluids, air or water, with stationary or moving objects. And we can apply that to the aerodynamics of cars or trains, to wind loading on buildings, to wave power, or even the performance of a carburetor. Statics and dynamics is all about the application of forces to an object and the properties of the materials that are used to construct that object. We want to be able to predict whether a structure will bend or fail. We want to be able to describe and limit vibration and noise. We want to be able to predict the failure of an artificial hip, for example, from wear. In control, we look at rotation, coordinate systems, we look at calculus. And we do this in order that we can describe the motion of, for example, of a robot arm so that it can repeatedly and reproducibly weld a structure. Or in fact, in terms of control, we want to be able to accurately control the temperature in a room. So that's a broad overview of the course itself. Career outcomes for graduate mechanical engineers are wide and varied. They could be in the energy sector, where an engineer would look at planning, maintenance, or even revolutionary design of new energy harvesting systems. Could be in the rail sector, where they would look at track maintenance, new materials for rail, or indeed in the way those rail assets are used, such as in the mining sector, the maintenance and monitoring of the iron ore cars that take iron ore from the mine to the port, in logistics, and in mining itself, in the actual management of the ore resource. They might end up in the transportation industry, where they're looking at the aerodynamics of cars or planes or trains or trucks increasingly, new ways of powering those vehicles. In materials itself, in the design of new alloys for weight saving or sustainable use of materials, or indeed at the other end of the life cycle, the forensic investigation of a failure.